Hi all.
Welcome everyone. Good evening.
Very good. Good evening.
Good evening.
Good evening, guys. Just give a moment. Okay, so I'm sharing my screen. So I believe you are able to see my whiteboard.
Yes, we are able.
Okay. So today's topic is NAT. Okay, so we are going to learn with reference to NATing. How does NAT work and all? Okay, and like the main we will like try to address the concern that how should I know that do I have to use a NAT or not? Okay. So see, it refers to NATing. Okay, so why do we need a NAT? Okay, so your IP address, okay, your IP address is divided into two parts, right? One is private IP range, private IP, and the other one is public. Correct? Now, can anyone tell me what are the private IP ranges for class A?
So we can subnet 10.0.0.0 to 10.255.255.255.
Okay, 10.0.0.0 till 10.255.255.255, correct? The other range? Class B?
103.172.2.
And class C?
192, 168.
correct? These are the IP ranges, right?
Yes.
And rest all, whatever the IP remains, those are public IP range, correct? Now, for an example, you have a PC, okay? The IP of the PC is 192.168.1.10. And this PC is connected to assume a router, and this router is connected to a internet. Now here, of course, this router interface will act as a gateway, so I'm calling it as port 1, okay? And the IP to that is 192.168.1.1, okay? Now, this is the public IP that is assigned here is 1.2.3.4, okay? Now, if I try to reach to the internet, let's say this PC is trying to ping 8.8.8.8, okay? So from this PC, I am pinging 192.10 is trying to ping 8.8. Now the router receives it. Router is doing the destination lookup, right? And once the destination lookup is done, it sees that, okay, fine, this packet has to be sent out via the port 2, okay? Now, the router is sending the packet out, okay? 192.10 as a source and destination is 8.8. So can this packet reach to the 8.8.8? Can this PC reach to 8.8.8? Let's say there is a server here whose IP is 8.8.8.8 over the internet. So can this packet reach?
No.
Why?
This private IP is actually after that reach that private IP, it's converted in public.
Forget about converting. I am saying if I do not convert anything, the PC is sending this packet, okay? This packet is received on the router and router is forwarding this packet onto the internet. Now will this packet reach this destination 8.8.8.8? Router can send it, right?
Yeah, Mr. Rohan, I would like to say something here.
Yes, please.
So, if the router is having the route for this 8.8.8.8, then definitely it is going to send the
packet.
Yeah.
Yes, it is going to send the packet. Okay. Yeah. So on the router, I am having a default route which says that anything should be sent on the port 2. Okay. Okay. So this packet is, so whatever the packet that it has received from the PC, it is sending it out to the internet. Right. Right.
Yes, yes.
So will this packet reach to the destination that is 8.8.8.8 since the packet has been sent out by the router? If yes, why? If no, why?
No.
No, why?
Why? Because it's a private IP. So the private IP cannot, the router port to interface 1.2.3.4, right? So the inside network, if any user wants to communicate with the ISP, the IP should be converted to 1.2.3.4. I mean, the 1.2.3.4, it will attach, this IP address will be attached to the packet. That packet will go to 8.8.8.8.
Why? If I do not do that, what is the problem then? Why I need to convert to 1.2.3?
Because this is a private IP address, right? I mean, uh, uh,
Yes, it's a private IP address 192.10.
IP is not routable on internet.
That is what I wanted to know. Thank you, Sanchar. See, although the router has sent this packet out, but this packet will be dropped at the ISP level. The ISP will drop this packet. Why? Because the private IPs are said that these IPs are not routable. Routable means you cannot send a packet which is having a source as in private IP range, okay, onto the internet. Why? Because the ISP do not maintain the routing table list for private IP ranges. Okay, so when that packet will reach to the internet will do the routing lookup, right? And when it does, it will say, hey, I do not know where this 192.10 is, and hence drop. This is why we say private IP is not routable. Okay, so now the thing is, whenever you want to reach onto an internet, you cannot directly send the traffic or the packet using your private IP. This is why you have to modify or you have to translate your private IP into the public IP. The process that you use in order to translate your private IP to public or vice versa, that means public to private, that is called NATing. Okay, network address translation. So here you do not only translate the IP, but there are certain situations where you may need to translate the ports number as well. When I say ports, I'm talking about the TCP layer information where you have source port and destination port. Okay, so that is something also which is translated. If you translate the ports, then such a translation is called PAT. Okay, see, one is NAT, one is PAT. Okay, now with reference to NAT, you actually translate IP address, and in PAT you translate port number. Okay, port number. Port number means the range that is from 0 to 65535. Okay, do not assume I'm talking about these ports, interfaces. I'm not talking about that. I'm talking about 443, port 53, port 8080, whatever that port is, okay? The services port. I'm talking about that. So if you translate the ports, you are doing PAT. And if you translate the IP, you are doing NAT. Clear? Clear? So the foremost need for the NATing is that your private IP is not routable on the internet. Hence, you need to translate this IP to the public IP. So when the router will send, it will not use the private IP. Rather, it should use 1.2.3.4, okay, as an source, and destination will be 8.8. That is how the packet should look like, because this is your public IP. So you will be sending the packet using your public IP addresses as a source. Okay. This is called translation. So you are translating the IP addresses. This is one foremost case. The other use case for the NATing is that you actually hides the identity of the sender. Okay. So see, outside, if someone sees, like here it's the 8.8.8. is thinking that he is getting the packet from 1.2.3.4. So 8.8.8 thinks that he is actually has got the ICMP packet which was originated from 1.2.3.4. Actually, this ICMP packet was originated by this PC, right? Whose IP is this? So by translating the addresses you have hidden the actual identity of your PC. So that even if someone has got the public IPs and all, your internal systems or for that matter servers are not compromised. Okay, so that's the two main reasons why you will be using NAT. Clear? Clear?
Yes.
Okay. Now, see here. So whenever you have any of those two requirements, okay, whenever you have any of those two requirements, you have to go with a NAT. Okay, there is no other options. You have to go with that. Now, how many types of NAT are there? Okay, how many types of NAT are there? So say, if you translate source, if you are translating source IP or source port, any of that, if you are translating the sources, such an translation is called source NAT. Okay. If you are translating destination IP or destination port or maybe both, okay, such an translation is called DNAT. Name is clear, right? Source NAT and destination NAT. So when I say that, hey, I am enabling source NAT, that means what I'm saying is I will be translating the source IP of the packet or maybe source port of the packet. When I say destination NAT, that means whatever the packet that I have received, I will be translating the destination IP or maybe destination port of that packet. Clear? Clear?
Yes.
Okay. Now see, how many types of NAT are there? Okay. See, I believe you guys know that there is IPv4 and IPv6, right? You have IPv4 address like 8.8.8.8. This is IPv4, right? Whereas IPv6 is 128-bit. Anyone here who has not heard IPv6? Hey, if you do not respond me, how would I know?
Yeah, we know about it.
Yes.
You have heard about IPv6, right?
Yes.
Okay, fine then. So see here. So based upon that, the NATs can be categorized as first type NAT, of course. Second is NAT 4.6. Third is NAT 6.4. Fourth is NAT 6.6. Okay. Now here you are saying that when the translation happens from IPv4 to IPv4 address, that is called NAT. You can call it NAT 4.4 as well if you want. Okay. 4.6 means IPv4 address is translated to IPv6 address. And IPv6 address here is translated to IPv4 address. And here IPv6 is translated to IPv6 itself. These are the four combinations that can be formed with reference to the names, like the two types of IP that we have. Okay. So if someone says NAT 4.6, NAT 6.4, do not get confused that, hey, what he is talking about. Okay. He's simply saying that I want to modify or I want to translate the IPv4 address to IPv6. Okay. So there is no change of the configuration, nothing at all. It's same. How we will do this one, the meaning will also be done in the same way. Okay. If someone is using IPv6, it's fine, not an issue. The firewall will process all the traffics, everything, the NATing table, everything is maintained in the same way. There is no difference. Whether you are doing NAT 4.4, NAT 4.6, 6.4 or 6.6. whatever you're doing. For me, it's nothing but NAT. Clear? Clear?
Yes, yes.
Now, we will first start with source NAT and then we will move to the DNAT. So let me start with the source NAT. Now, with reference to source NAT, in the Fortigate firewall, okay, there are two ways that you can implement the source NAT. What are those two ways? First is via the policy, or to be precise, via the firewall policy. In the firewall policy, I showed you yesterday that there is an option to enable NAT, and in the command line we say set NAT enable. Remember? No, right?
Yes, I remember.
Okay. Yeah. So when you can enable the source NAT from the firewall policy itself, or by using central SNAT. Okay, this is also called as central NAT. Okay, so I will show you how central NAT will look like. You will not be using it mostly. Okay, no one uses this, but if in case any one of you is willing that you want that, hey, it seems cool for me. I am happy with the way that the central NAT maintains all the NATing in a single place. So it's up to your call. Okay, so you do it via the first method or the second, it's the same. Okay, after all, you are going to achieve the same desired result. Okay, it's just the way to implement. Okay, now in terms of source NAT, okay, when you enable it, there are four. Yeah, I think there are four types of source NAT. Okay, there are four types of source NAT that is supported by your Fortigate firewall. The first one is overload. Okay, second one is 1, 2, 1. Third one is fixed port range, and fourth one is port block allocation. Okay, here are four types of source NAT pool that you can implement. Okay, so it's actually source NAT pool. Okay, now see, I will describe each and every one by one. But the main thing is, since I'm talking about source NAT, that means we are going to translate what? Either source IP or source
Port.
Okay, keep that in mind. We are only trying to see that we have to translate the source IP or source port, or maybe both. Okay, whatever you want.
Ron, what's the like meaning of source port means?
Source port means,
Yeah.
in TCP, it's like, how would I say? Okay, in TCP header, you have source port and destination port, right? Source port is some random value 44659 and destination port is 443. Not getting that. Okay, let me show you. Let me show you that. TCP, source port, destination port.
Oh, okay.
It's like, are you familiar with this, or?
Yeah, but like in so I mean, like why we are using source port in the netting?
Why you are using source port?
Yeah.
You are not using source port.
like you said, like, two ways, right? Source IP and source port.
No, not two ways. I didn't say two ways. The two ways to implement the source NAT is either via the firewall policy or via the central SNAT. So I said that when we talk about source NAT, that means I may translate the IP, or sometimes I may also need to translate the source port.
Okay.
Yet we are talking about source NAT, right?
Yeah, yeah.
So that means I am going to translate only the source. Translate means what? Translate means what? You are sending me an IP 192.168.1.10. I will translate that IP to 1.2.3.4.
Yeah,
Right?
that I understood, means the source IP understood. But I'm asking like source port means in the netting, like.
Yes, you may come across a situation where you have to also translate the source port. Okay, if you have to do that, the like firewall will do it on behalf of you. Now the question is when I will need it, right?
Yes.
Just give me 5 to 10 minutes. I'm going to come on to that point when the patting will be done. Okay.
Okay.
Okay. So PAT is nothing. See, I used a term, right? PAT. PAT means port address translation. Okay. So when you translate a port, we call it as PAT. Okay. Source PAT or destination PAT. Okay. Okay.
Okay. Okay.
So I want everyone to be on the same page. For now, what I'm saying is source NAT means you are going to translate the source IP or source port. Destination NAT means you are going to translate the destination IP or destination port. Is that point clear?
Yes, that is.
Yes, Ron.
The terms are clear?
Yes.
Okay, fine. Now moving to the next step. Okay, so leave all those thoughts to me. Okay, let me complete. Okay, I will give you the complete insight. Okay, when, what will happen and how you will take a call. Okay, step by step. So that first point is clear. What is source NAT and what is destination NAT? Now, I want you to focus on source NAT. So in source NAT, if you want to configure on the Fortigate firewall, there are two ways. Either you enable that on the firewall policy, or you can do the same thing with reference to central NAT. Okay. So what is central NAT and all? We will see it later on. It's just a configuration thing. Okay. So leave that part as well for now. Now, in source NAT, okay, in order that, hey, you want to translate and the source IP, okay, or the source port. So how you will translate that? So in order to do that, there are 4 different types of SNAT pool, source NAT pool, okay, or you can say types of 4 source NAT. What are those 4 types? Those 4 types are: first is overload, second is one-to-one, third is fixed port range, and fourth is port block allocation. Clear? Clear?
Yes.
Now let me explain you each type one by one. Okay. Now see, overload is the default SNAT. Whenever you enable the source NAT on the firewall policy, actually you have enabled overload, which is also referred as outgoing interface IP. Okay, to be like in an easiest way. So if I show you the policy here, see here, I will show you the configuration at the same time, so that will start making much more sense. Okay, see here. Policy and objects, firewall policy. Okay. And here, if you open the policy, you see this option, NAT turned on. So when you turn this on, you are actually enabling source NAT. And here when you enable, see, when you enable, by default, what is selected? Use outgoing interface address. That means it is saying that, hey, you have to translate the source IP to the outgoing interface address. That means what is your outgoing interface? Port 2. So whatever the packet that will be sent, that will be translated with reference to this IP. The source IP will be translated to 10.0.2.250. Clear?
Yes.
So this is why I told you that this is by default, right? So this, what it does, so what it is doing, many to one, right? So maybe there are 100 of systems who are sending the traffic to the internet. Every 100 system is matching this policy, right? So it is doing source NAT. So it is saying, hey, you have to translate all these source IPs to whom? To outgoing interface address. Clear? Clear? That is referred as overload. That is referred as overload. Now let me show you here. You see IP pool. Okay, this is source NAT pool. Okay, the types of source NAT that I was talking about. Okay, so I'm doing a create new. Now see here, 1, 2, 3, 4. Overload, 1 to 1, fixed port range and port block allocation. Clear? So overload is nothing but what you just did there. Use outgoing interface address. Okay, there you only had the option to translate all the IPs to a single IP that was assigned to your outgoing interface. Whereas if you choose overload, it's the same thing, but here you can define the range as well. That, hey, I want to translate it to public IP. Say, I'm giving 2 public IPs. Okay, so everyone will be translated to 1.2.3.4, and as soon as the 1.2.3.4 is completely utilized, then it will move to 1.2.3.5. Now what I said, 1.2.3.4 is completely utilized. What do I mean by that? When I say that this IP has been completely utilized. Now focus on this point, okay? I really want, if you have doubts, ask me the question again. But do not miss this. See what I'm saying. Let us take the example of 2 PC to keep it a simple one, okay? PC1 and PC2. Let us take an example of that. PC1 IP is 192.168.1.10. PC2 IP is 192.168.1.20. Okay, they're in the same subnet. They are connected to a switch. The switch is connected to the firewall. Since we are learning a firewall, so I'm taking a firewall. Okay. Now this firewall is connected to the internet. Now here there is a server. That server IP is 8.8.8.8. This interface is port 1 and this interface is port 2. The IP of port 1 is 192.168.2.1. Clear? Port 2 is let's say port 2 is a ISP, right? So I'm giving a public IP 1.2.3.4. Clear with the architecture? Fine?
Yes.
Everyone is fine?
The port 1 IP address is 2.1 or 1.1?
Raju, okay, thank you for noticing that. Okay. See, I will keep on writing bad things, okay? I need your focus. 1.1, okay? It should be same range. Gateway cannot be in a different, okay? Subnet, okay. 1.2.3.4. Fine now? Topology is fine? Here?
Yes.
Okay,
Yes, yes.
now see here. I want, now see, my PC1, okay? My PC1 is sending the packet. So the source is 192.168.1.10. Destination is 8.8.8.8. Correct? This is the packet sent on to the switch. Switch is forwarding it to the Fortigate Firewall. Yes or no?
Yes.
Fortigate has received this packet. Now, Fortigate, if the Fortigate sends the packet as it is, the ISP will drop it. Why? Because the private IP is not routable. Correct? Correct.
Yes, correct.
So that's why you have to modify the source IP to public IP. That means private IP to public IP. This is why you are now going to enable what? Source NAT here.
Yes.
Correct?
Yes.
If you, let's say you have enabled the source NAT, okay, you have configured the source NAT here on the Fortigate Firewall. Now, since the source NAT is configured, now your source IP, the packet which is sent by the Fortigate Firewall, the Fortigate Firewall will modify the source IP to 1.2.3.4. Destination will be 8.8.8.8. Clear?
Yes.
This is the packet that will be sent to the internet. Right? Right. And the ISP will be sent just like this server whose IP is 8.8.8.8. He will receive that packet. Correct? Now it will try to form a reply. Now it is sending a reply. When it will send a reply, the source will be 8.8.8.8. Destination will be what? 1.2.3.4.
Yeah. Yes.
Right?
Yes. Yes.
Okay. So this is the packet. This packet has been sent onto the ISP. And ISP is forwarding it to whom? To the Fortigate Firewall.
Firewall.
So when the Fortigate Firewall receives this packet, will the Fortigate Firewall send this packet as it is? No. It will translate this back. So it knows. See, when here it performed the source NAT, okay, at that time, the firewall maintained a NATing table. Okay, there is a NAT table that the firewall has maintained, and where it has said that, hey, I have translated 192.168.1.10 to 1.2.3.4. Clear? Clear?
Yes.
So
Yes.
when there is a reply packet, and since that packet will match with the existing session, hence the firewall will know that, okay, I have got a reply, so now I have to translate this IP back to the actual IP, right? So this is when the firewall will send the packet out, he will send like this: source NAT Oh, sorry, as source is 8.8.8.8, destination is 192.168.1.10. Since it is translating the destination back to the actual IP, that's why this NATing, here also the IP is getting translated, right? So this kind of NAT is called reverse NAT or destination NAT. Clear?
Yes.
Clear?
Yes.
Now, yes. So this is the packet which will now be sent to the switch, and switch will then send it to the PC1. Correct? So PC1 has got the reply? Yes or no?
Yes.
Now, similar to that, okay, with the same concept, for an example, let's assume we have PC2. Now PC2 is sending the packet. The source is 192.168.1.20. Destination is 8.8.8.8. So it is also a ping packet, okay, the same thing. Same packet has been sent to the switch. Switch is forwarding it to the FortiGate. FortiGate will perform a source NAT, right? When it will perform a source NAT, and then the packet what it sends out will look like this. Source is 1.2.3.4. Destination is 8.8.8.8. Correct?
Yes.
Here also it will maintain one more entry that I have translated 192.168.1.20 to
1.2.3.4.
Correct? Now,
Correct.
it will be sent to the ISP. ISP will send it to the desired.
Server.
Now, the server will try to form a response. The server is trying to form a response. When it will try to form a response, the source IP will look like 8.8.8.8. Destination will be 1.2.3.4. Correct?
Yes.
Now this packet will be sent to whom? ISP.
ISP.
ISP will forward it further to
Firewall.
Firewall. Now firewall has received this packet. So it is a match of the existing session. Hence firewall will see, okay, I have got this. So I will translate this IP back to the actual IP. Now it will go into its NATing table. Now here there is a big confusion.
Rohan, I have a question actually. This is many to one, right? So how netting tables aggregate the traffic?
Sorry, can you please come again?
Actually, this net is many to one, right? So how firewall understand which packet need to send? It depend upon net table only.
Which packet needs to send?
For which destination? Actually, if we have 10 hosts, right, and 10 hosts have different IP, okay. If 10 hosts are trying to search like YouTube, google.com, right? So how firewall will understand which packet we need to send which host? So it depend only through net table.
No, that access control policy.
That is with reference to policy, routing, lookup, and all those things, man.
Yeah.
No, but how net translation will work?
So just wait, please. I was in middle of that point. Okay, just okay. See here. Okay, where I was. Okay, so this is responding right here. So when the FortiGate receives this, now the FortiGate is saying, okay, I have to translate this IP back, right? 1.2.3.4. He has to translate this back. Now he will go back to the NATing table. Here he sees two entries.
Yes.
Now the firewall is confused. Do I have to translate 1.2.3.4 to 1.10 or 1.20?
Yes.
Correct?
Yes.
who he should do, correct? So that's a conflict. Okay.
Yes.
So how does the firewall know exactly that, hey, this reply will be sent to PC2 and this one will be sent to PC1? How does the firewall know that? That is where, okay, that is where the port come in picture.
Okay.
Okay.
Yeah, that's
See,
that was the question.
say in a session, okay, like when I was discussing about the firewall policy, I told you there are 5 important things, 5 tuples, right? That must be exact same, then only it is said that a respective packet is matching a particular policy or a particular session, correct? What are those 5 tuples? Source IP,
Source
port,
IP, destination IP, source port, destination port,
and protocol number.
protocol.
Correct?
Yes.
Yes.
See, same concept here also. Okay. Every packet is unique. How? Because when this PC1 sent the packet, okay, it not only sent the IPs, but at the same time, it also sent what? Port number.
Port number.
Okay. And source port is always a random port. Clear?
Yes.
So how does the packet is actually looking like? The packet is actually looking like this. It is saying that the source port is 4469. Okay. Here also your source port, okay, your source port will be saying, source port, you will say that it is 5543. Okay. So when the NATing table is maintained, it not only maintains with reference to IP, but at the same time, it also maps. Okay, so it maintains like this. 192.168.1.10 with the source port 4469 is translated to 1.2.3.4 4469. Okay. And the second entry will be maintained as 192.168.1.20 with the source port 5543 is translated to 1.2.3.4 to the source port 5543. So please have a notice here. Note that only the IP is getting translated.
Yes.
But your source ports are not getting translated.
Okay.
Clear? So see, here, if this is how the entry is maintained, instead of this, then there is no confusion because, see here, when the packet will be sent out, here it will maintain that the source port is 4469, right? Correct? When there will be reply, the reply will say the destination port is 4469, right?
Yes.
Similarly, here also when the translation will happen, it will say the source port is 5543. But when the server will reply, he will say destination port is 5543.
Yes.
So now when the firewall receives this packet, the firewall knows, okay, fine, I have to translate 1234 IP whose port is 5543. Now in this table, it is matching with this, right?
Yes.
So it knows, okay, fine, I will translate it to 1.20. Hence, when the firewall will send the packet out, the packet will look like this. Source says 8.8.8.8. Destination IP is 192.168.1.20 and destination port is 5543. And this is the packet that will be sent to the switch and switch will further send it to the PC2. Clear? Clear?
Yes.
Okay. So
Clear,
this is how the uniqueness should be there. See, if there is no uniqueness, okay, there is a conflict because firewall cannot take a decision. Not firewall, any NATing device cannot take a call because if there are 2 entries for the same IP, How will it know that I have to translate it back to whom? Price. So there should be something unique, something that something, which is port number. Now, here, so till this point, it is clear. Before I proceed further, is it clear?
Clear.
Yes,
Yes.
Yes, yes.
Okay, now see
Can
here.
we Rohan, do this on practical, because like
I will show you. Do not worry. I will show you. Please be okay. Everything.
Rohan,
Yes. Yeah.
Rohan, I have a question. If PC1 and PC2 is accessing same website with port number 443,
That is destination port, right?
so in that case, how NAT table will?
Destination port, na? 443 is what? Destination port, right?
Yes.
So what it's like, does it matter? Think na. Destination port here is 443 for an example. Here
Yes.
also destination port is 443. Okay.
Yes.
Translation is happening for what? Source. Correct. So your destination port still remains 443.
Yes.
When there will be a reply, it will say source port is 443.
Yes.
Correct. So when the reverse NAT will happen, the reverse NAT will happen for this, right? So what's the point? Whether your destination is 443 or whatever it is, that doesn't matter, right? You're translating sources now. You are translating what? Source.
Source IP.
So what it matters, what is in your destination? Not getting a point. Okay, fine.
But port remain same for both.
Leave it. Okay, leave it. Let us start again from scratch. Okay, again. See here. You have a PC1, okay? That PC1 IP is 192.168.1.10. Okay? I am going to do a DNS packet. Simple.
Yes.
Okay,
Yes.
DNS packet. Everyone will do a DNS packet. Okay. Now, see here. The topology is PC is sending to the Fortigate. Fortigate is sending to the ISP, over where you have a DNS server that is 8.8.8.8. Clear? Clear?
Yes.
Now, I am forming the packets now. PC1 is sending a DNS packet. Source IP 192.168.1.10.
Yes.
Source port, any random port, 4463.
Yes.
Destination IP 8.8.8.8.
Yes.
Destination port 53.
Yes.
Clear up to this point?
Yes.
Packet sent to the Fortigate firewall. On Fortigate, you have enabled source NAT. So your firewall is now doing the
Static.
source NAT. Okay.
Yes. Yes.
So source NAT means what? Source NAT means what? Translating?
Private to public.
Private to public.
No, wrong. Source NAT means translating source IP or source port.
Yes.
Source IP. Source.
Source IP.
Okay.
Yes.
So it is translating now. Let's assume here
Is
the
source IP
public
and source port, na?
Yes, either of that or both. But the point is source. It is translating source. Okay. It can be IP, it can be port, or it can be both. Clear?
Yes.
The term is clear, source NAT. The term is clear, brother.
Yes. Yes.
Yes,
Okay.
yes, yes.
Let's assume the public IP is 1.2.3.4. Okay. So your source IP is getting translated to 1.2.3.4.
Yes.
Here, your source port is same 4463. I am not translating your port. That is your source port. I am not translating your source port. The source port remains same. Clear?
Clear.
Destination IP. Do I have to translate destination IP? No.
No.
Because I have enabled source NAT.
Source net.
So there is no
Yes.
need to translate the destination. Destination port, am I translating destination port? No. So
No.
destination port also remains 53. Packet is sent to DNS server.
Yes.
Now DNS is responding. When it will respond, the source IP will be what? 8.8.8.8. Source port will be what?
53.
Yes, 53. Destination IP will be what?
1.2.3.
1.2.3.4. Destination port will be what?
4463.
4463. This is the packet response. Coming
Yes.
to Fortigate. The Fortigate has maintained a NATing table when it did this, right? So what it maintained, that I have translated 192.168.1.10 for the port 4463 to whom? 1.2.3.4 44. Okay, let me take some more space. One 192.168.1.10 to with the source port 4463 has been translated to 1.2.3.4 with the 4463. Correct?
Yes.
So when it will do a reverse NAT, the Fortigate will do what? They will say source IP is what? 8.8.8.8. Source port is what? 53.
53.
Destination IP will be now modified. Reverse NAT.
Yes. 192.
1.168.1.10 and destination port will be
4463.
4463.
4463.
Now this is the packet that will be received on the PC1.
Yes.
Yes.
So even if you have PC2 who is trying to reach to the same DNS server, does it make an impact? Because when the PC2 will send, PC2 will have a different random source port.
Okay.
So is there any chance of conflict?
No.
That's not possible, right?
Yes.
Ideally. So clear?
Yes.
Yes.
Yeah.
Okay.
Clear.
Now, see it.
No, I have one question.
Yes, please.
Yeah. Is there any relation between NATing table and policies?
NATing table and policy.
Yeah.
There is no difference. There is no connection.
Okay.
Okay. There's no connection. Because if you see the life of packet, first DNAT happens, then routing lookup, then policy, right? After the policy lookup, UTM, and then source NAT. So there is no link up. Okay.
Okay.
So did you see this clear up to this point?
Yes.
Up to this
Clear.
point? Okay. So I will show you the NATing table. Okay. Do not worry. I will show you whatever I have told you. It's my responsibility to prove you. Okay. So I will show you that. Do not worry. But first I want to have your basics clear. Now, see it. Now, I told you that here the ports are not getting translated. The source ports are not getting translated, right? Correct?
Yes.
So let me show you the configuration first. Overload, right? So let's say I say 4. That is a single IP. So if I say this, so now all the private IPs will be translated to 1.2.3.4. Clear?
Yes.
Now, do you see any configuration related to porting here that I can translate the port? No.
No.
There is no configuration for port, right? Now let me tell you one thing. Patting is something which happens automatically, and that too, the call is taken by the firewall. So how, and whatever I'm telling you right now is with reference to the behavior of any L3 device, irrespective of the vendor and irrespective of the product that you're working on. This is how the NAT functions. Okay. See, patting is something which is unless you, exception of the few cases where you intentionally have modified or you want that a certain port should be modified. Okay. That too, what you do it is in terms of destination, but not in source. So, okay. So in sources, that call, the patting action is defined. Okay. Please be on mute. Please be on mute. You're not having, please be on mute, ma'am. Please be on mute. Okay. See here. So, okay, where it is. Source NAT, yeah. So, see, the patting action is decided or is taken automatically. Okay. Now, what is that trigger point? How does a device know that it has to translate the port? What is that condition? Now, let me tell you one thing. What is that condition? For an example, somehow assume, I'm again saying, somehow two systems generated the request for same destination with same source port. What I'm saying is, like here I'm taking the same example, okay? The PC2 now. Let's say PC2. He's also sending a DNS traffic, okay? Now, somehow the IP of this was 192.168.1.20. Source port, he also ended up using 4463. Okay. Destination IP is 8.8.8.8. And destination port, of course, is 53 because he wants to access DNS. So he's sending this packet. When he sends this packet to the Fortigate, Fortigate is now doing a source NAT action. When that action is performed, the Fortigate translated the source IP to 1.2.3.4. Source port is 4463. Destination IP is 8.8.8.8 and destination port is 53. Now this is the packet which is received on the DNS. And the firewall is also maintaining an entry that, hey, I have translated this 1.20 who came up with the source port 4463 and I have translated to 1234 with the port 4463. Now, when the DNS will send a response, he will send like this, that the source IP is 8.8.8.8, source port is 53, destination IP is what, 1.2.3.4 and destination port is 4463. When this packet will be reached on the Fortigate firewall, Fortigate firewall will try to do a reverse NAT, right? So it will see this entry as well as this entry. It is the same. Yes or no? The IP and ports are same. Now again the firewall is confused. What I should do? Yes or no?
Yes.
So this is why, as a, it's like I would say it's like proactive measures. Okay, you can say proactive measures. What happens is, actually this is not how the NATing will be done. When such an entry is created, the firewall will automatically see that, hey, it's a conflict. Okay, I cannot maintain this entry because I am having the translation for the same IPs with two. It's like 1.10 is also mapped to 1234 with the same port, as well as 1.20 is also translated to the same IP with the same port. So when I will get a reply, I will be confused. It will conflict. Hence, what it will do is, it will say, no. Instead of having 4463, I will make it as 8863. So it will now, it is not only translating the IP, but it is also translated the source port. So here it will modify 8863 as well. And when the response will be coming, he will also use the same thing, 8863. Now it is unique, correct?
Yes.
So that is, now you can say that, hey, here the pattern has taken the place. The part has taken place. Okay. Now, clear? So when
Yes.
does the part happens? When there is a conflict. That means if two systems accessing the same destination, okay, ends up with the same source port, that is where the issue will happen. Clear?
So, yeah. So PAT is done by firewall automatically.
Automatically.
We no need to configure that one. Okay.
In terms of source part, you do not need to configure.
Okay.
It is automatically taken care. Now you may say, hey, is it some kind of an hypothetical situation that I'm talking about, or is it something really that happens? Now let me tell you, it is a real case that happens, and this happens often. It is not something once in a blue moon. Why I'm saying that? Now please note, see here, after all, the uniqueness is depending upon what? Source port, right?
Yes.
And how many source port you have? 102.4.2.65535, right?
Yes.
You only have these many source ports.
Yes.
So how many it will come? Around, I think, 64,000 something, right? So that means you can have 64,500, what is that? 64,511 unique sessions. Maximum you can have on a single IP. Yes or no?
Yes.
So do you think that it is enough for someone who is working in a production network?
No.
It can be easily occupied, right?
Yes.
So it's not a random thing because you have a limited number of source port. So it happens when you have a very high amount of traffic dealing, okay, where your device is dealing with a very high amount of traffic, there is a very, very high potential chance that you may come across such a situation. Okay, clear?
Yes.
I have one question.
Yes, please tell me.
Yeah, then how the firewall differentiate the duplicate packet?
Duplicate?
Yeah.
Now give me a situation there.
Hello?
Yes, what do you mean by duplicate packet?
No, you are telling that this port will be translated, yes? If again it is on the same thing. So what is the case if the same port is sending the same packet again?
Same port is sending the same. Can you give me a situation, brother? I'm actually not getting a question.
No, means that you are telling that 192.168.1.10 4463 and from the another machine 1.20 on the same port. Yes.
Yes.
Okay. Here there is no case of duplicate packets. Yes.
Okay. There is no duplicacy here.
That's so I thought that from the same machine. Okay. Same sender. Yeah.
I got it.
Okay.
Okay.
Yeah.
Fine. So you okay. So now coming back, overload. Overload is called as many to one. Okay, this is referred as many to one. That means multiple clients will be sent out using a single public IP, LAN to WAN communication. Clear? Clear?
Yes.
So in overload, your NAT happens and PAT can also take place depending upon if in case it is needed. If there is a conflict situation, the firewall will automatically translate the port. Clear?
Rohit, please come again. Please come again.
I am repeating the same thing which we just discussed. Okay, I'm saying if in case the situation happens where the conflict may happen, the firewall will automatically perform a patting. Do you want me to repeat that again or is it clear?
Yeah, clear.
Clear?
Yeah.
Okay, so that's why I'm saying overload is nothing but many to one. Okay, that means there are multiple PCs. All PCs will be translated to a single public IP and henceforth will be sent to an ISP. Hence, the IP will also be translated, and if in case it is needed, it also can translate the ports. That's why overload supports NAT as well as PAT. Yes.
Yes.
Okay, now see 1-to-1. The name is itself clear. What is 1-to-1?
Yes.
1-to-1 means, hey, I want to map. Okay, I want to map one IP to the other. Let's say, for example, I've said 192.168.1.10. Okay, now I'm saying 192.168.1.11, 192.168.1.13. Oh, sorry, 12. Okay, and 192.168.1.13. Now, in 1-to-1, if I create a pool, the pool is 1.2.3.4 till 1.3.3.6, for example. So what will happen is 1-to-1 map. If the first packet that I have received is 1.10, so 1.10 will be mapped to 3.4.
Yes.
Here,
yes.
If the second packet that I have received is from 1.12, the 1.12 will be mapped to 3.5. Okay. And if, let's say the third packet which I have received is from here, 1.13. So 1.13 will be mapped to 3.6. And if I receive the fourth packet that is from 1.11, now there is no IP left in the pool, right? So this packet will be dropped. Clear? Oh, sorry. Yes. I ended up. Clear?
Yes.
That's 1-to-1 NAT, right?
So that is 1-to-1 NAT. Okay?
Okay.
Now, the other one is fixed port range. Okay? Now see, yes, one more thing that I wanted to tell you, okay? One more thing is that in 1-to-1 NAT, in 1-to-1 NAT, only NATing happens. That is the IP is translated, okay? Only the IP is translated, but the PAT is not performed. Okay, there is no PAT. Clear? The patting action is not performed in 1-to-1. It's simply IP to IP. Okay. So it's like first come, first serve. Whosoever comes first, he will be mapped to the first IP. And whosoever comes next, he will be getting subsequent next IP, next IP, next IP. And if all the IPs in the pool is occupied or has been allocated, then the others packet will be dropped. Clear?
Yes. Rohan, sometimes we allow the RDP for private to public. So that is the example of 1-to-1 NAT.
Hence you allow.
Yeah, that's also. Ron, is it also called static NAT, right?
Yeah, it is also called a static NAT.
Okay.
Static NAT. Okay.
Yeah. Okay. Now, but in true sense, the static NAT is the one which I will tell you afterwards. Okay, so that is fixed port allocation.
Oh, I see.
Okay, that is fixed port range. Okay, so that is something which is actually a static NAT in a true sense. Okay, how? See, fixed port range is nothing but the combination of one-to-one and overload. So what I mean by that is, in fixed port range, okay, you will also be getting the same thing. Okay, that you have to define the range. Okay, so you will say that, hey, I will be defining the range of saying that, okay, let's say you will say that my NAT IP pool range is 1.2.3.4 to 1.2.3.6. Okay, and you will say that my internal IP range, okay, or you can say private IP range is 192.168.1.10 till 192.168.1.12. Okay, so when you define this now, then what it happens is that always your 1.10 will be translated to 3.4. Your 1.11 will be translated to 3.5 and your 1.12 will always be translated to 3.6. Clear? Clear?
Yes.
It is one-to-one map. It's like exactly static NAT. It's like you want that my 1.10 should always be translated to 3.4. 1.11 will always be translated to 3.5. 1.12 will always be translated to 3.6. Now, what's the difference between one-to-one and fixed port range? The difference is in one-to-one, whosoever came first, he got that IP, right? 1.10 came first, he got 3.4. After that 1.12 came, he got 3.5. It's like whosoever came first, he got that IP, right?
Yes.
But here in fixed port range, fixed means you have fixed. Now, even if the 1.12 arrives first, he will always be getting 3.6. He will never get 3.4, right? Clear?
Yes.
That's why we are calling this as fixed port range. Okay? Okay?
Yes. Yes.
Fixed
Now,
port range means this port means port or IP.
no. I'm like coming to that. Fixed part is clear. IPs,
Yes.
exact match. Now the port. Here it says that, hey, I have a behavior of one-to-one, right? It's the same kind of an one-to-one behavior. I am mapping it one-to-one. But unlike one-to-one, where the PAT is not supported, I do support PAT. That means if in case there is a situation where the conflict may happen with the, let's say this is a server. Okay, 1.10 is a server. He is responsible to generate lot of sessions. Okay, lot of sessions. So there is a possibility that he can come up with same port. Okay, and if that happens, there should not be a conflict. Okay, so here the patting will automatically be supported. Clear? Clear?
Yes.
So in fixed port range, the PAT is also supported. Okay. Now, port block allocation. Okay. Okay. Before that, let me show you. Oh man, I again ended up where it is. Come on. Okay. See here, so 1 to 1, right? So see, 1 to 1, you will simply define the range like I mentioned, 1.2.3.6, okay? And whosoever comes first, he will get the first IP, then the next, then the next, and then the next, okay? There, no PAT is supported. The patting is not supported in this. Whereas in fixed port range, you will like here, to 1.2.3.4 to 1.2.3.6. Here you will define, say, 192.168.1.10 to 192.168.1.12. Okay, it's done. So 1.10 will be mapped to 3.4, 1.11 will be mapped to 3.5, and 1.12 will be mapped to 3.6. Clear? Clear?
Yes, yes.
Yeah, clear.
Now, you see there is one more option, ports per user. If you say 20, okay, sorry, minimum value is 32. Okay, so 32 or increase it, 320, whatever you want to give, you can give it. Now, what is this ports per user? See, ports per user means a single source machine, that is 1.10, can form how many sessions at a time. So simultaneously, or like at a time, 1.10 can have 320 unique sessions. Okay, he cannot have more than that. So you are limiting the session count that each user can form a session. Okay, so that's ports per user. Okay, clear?
Yes.
Clear? Now, see here, that was fixed port range. Now see here, port block allocation. That's the fourth one. It's a very interesting one.
There is one more option. So up reply.
ARP reply is in everyone. Okay. I will answer this in the last. Okay, that why you need to, like what will happen if you turn it off or if you turn it on.
Okay.
I will like let you know on to that. So see, the last one is port block allocation. Now what is that port block allocation? See, port block allocation says, see, this is block size. Okay, block size means how many ports that you are giving in a single block. Okay, so you are saying that there are, to keep it simple, okay, I will give it as 100 for an example. I'm saying 100 ports in a single block. And how many blocks per user? 8. So that means a single user can have how many ports? 8 into 100, right? A single block is having 100 ports. And if I give you 8 block, that means how many ports?
800.
800. So that means you are saying that a single IP can have 800 unique ports. When you say ports, which port? Destination port or source port? Source port. You are learning source NAT. Okay, it's all about source NAT. I think I have a message. I have one doubt. Let's say 1.2.3.4 to 1.2.3.6 are 3 public addresses, right? Then what if we have only one public IP? Okay, yes, if you have only one public IP, you give only one public IP. If you have only one public IP, you will be going with the overload. Okay? Many to one. Clear?
Yes.
Funny now? Clear? Okay, fine. So say port block allocation says that a single IP, it's like if a translation is happening onto a single IP here, 3.4. Now each user can have how many? Can have how many source ports? That is unique sessions. So each user can have 800 unique sessions. That is here. Now let me tell you one thing. I was actually not this port block allocation. Okay, and you will rarely see someone using this. But let me tell you one example. It's like where I saw this. Okay, I think that will be a good discussion point at the end. Okay, let me show you the CLI. Okay, let me show you the CLI first. How does it look like? Okay, so whatever you configure here now, so let's say we will configure this and we will say my NAT. I'm just giving a name. Okay, press OK. And you go into firewall policy. Let me first complete this, then I will tell you one use case. Okay, troubleshooting case where I got to know that there is such a pool. So here you can say you can either use outgoing interface addresses or use dynamic IP pool. Select it, you will get your MyNAT. Okay, so which you create for overload. You choose that and it will start doing the source NAT translation with reference to the NAT IP pool, what you have called here. Clear? Clear?
Clear.
Now, see here. See, I may not be able to show you the patting action, okay, because for that I have to utilize 65,000 ports, okay, at the same time. And here in the lab, that is not possible to do, okay. So let me show you how you can check the NATing pool. Get system session list. See here. See, it is very easy. Okay, the outputs are very easy. See how it is written. Protocol number, how much it will expire, source NAT, destination NAT. Okay, see what is saying. It's a UDP protocol which will expire in 112 seconds. Source IP is 1.10. Source port is 50022. Source NAT. So this IP was NATed to 10.02.250. Right? See, the source port is the same. So source port translation has not happened. Destination IP, destination port. There is no destination translation. So only source NAT took place. Clear?
Yes.
This is how you will read the outputs. Okay.
I have one question.
Sorry?
Yeah, I have one question. Hello?
Yes, tell me.
Yeah, sorry, actually I'm new to firewall. This one, this private to public, will it happen automatically in the firewall?
No.
So where we will define this one?
See, you are doing it, na? Use outgoing interface address.
No, what I'm telling is private to public IP conversions.
That is what I'm also saying. Private to public IP conversation. NATing, right? Source NAT. Use outgoing interface address. So your packet is coming with 192.168.1.10, which is getting translated to outgoing interface address. That is, see the topology. Source is this.
Yeah, okay.
Who wants to reach to the internet?
Yes.
So source IP 192.168.1.10.
Okay.
Destination IP is something like 8.8.8.8.
Okay.
So when that packet is received on the Fortigate Firewall, you have configured a policy where you have enabled the source NAT.
Okay. Yeah.
Here what you have told, use outgoing interface address. That
outgoing
means translate the source IP. Sorry.
This outgoing interface is port 2, yes?
Yeah. Port 2.
Okay.
Yeah, IP facing link. Okay?
Yes, okay.
So what is the port 2 IP? 10.02.250?
Yes.
No, it is unknown, no? This outgoing interface. This is from the ISP or external server.
Read it. Use outgoing interface address. Outgoing interface address. What is the address of port 2?
Okay. 10.0.2.250 is not same in the network diagram, yes?
Sorry, it is not?
Same as in the network topology, our network topology.
So where is the confusion, brother?
No, so here where is it defined, the 10.0. that IP?
It's a DSCP learned IP, na? I was like, have you attended my first class?
Yes, yeah, I attended. So that's what I'm telling. It's DHCP IP, dynamic IP. Okay, fine.
But Ron, whenever I try the internet, means in Google, what is my public IP? So that time he showing same IP, same public IP.
Which 10.0.2.250?
No, 103. That means that IP is not changed. Only that's allocate for that same.
See, the actual public IP is different. That is of the network kings. Okay. Here, for me, the port 2 IP, what I am getting, I will treat this as a public IP. Okay.
Okay. But when I just search it now, what is my public IP? That one is different.
Of course, that will be different. 10.0.10.0 man. 10 series is private IP range.
So no, just Google what is my IP address now. That time, that which IP is I gave that IP means that this is my public IP, right?
But as per the diagram, I think we should follow whatever diagram has IPs. So port 2 is outside interface. It has IPs 10 dot. Right? One?
Yeah, correct.
Yeah. So yeah, you just need to follow that, and because I think you guys can confused on like public to private. So here is different pictures. Here is he's just showing the netting stuff, right? You don't need to concentrate on what IP is port 2 right now is. You just need to see is 10 dot network is coming to the other network. That's all.
See, this is what happens. Okay, actually, if you do not have the base, it's like what would I say? Do not follow the statements. Okay, have your fundamentals. The NATing is not about translating private to public or public to private. It's not. The NATing is simply translation about IP to IP. That IP can be private to private, public to public, or private to public, or public to private, anything. If an IP is getting translated to a different IP, that is NAT, in short.
That is correct, yeah.
Thinking that the NAT is only private to public or public to private, that is a half-baked knowledge. Okay. Let's say you want to communicate between two different internal LANs. One LAN subnet is 10.0.0.0/8 and the other one is 192.168.1.24. If that happens, you have to translate there as well, right? In order to achieve the communication between two different subnets, you may end up doing the NATing, right?
So how does get it that public IP address 125? So how does get it that public 125.20.16.186?
See here, that is ISP IP.
That's an ISP, yep.
That is a common ISP IP. Network Kings Lab is having this public IP posted. For us on this IP, there are several hundreds of labs working right now.
So when I that searched in our Google in our office network, so that time what is that time there is showing our firewall IP, firewall public interface.
It is not true. It can be true, cannot be. Okay. Unless you have the complete topology, you cannot be sure of that. If the ISP link is directly connected to your firewall, of course, then you are seeing the actual public IP that is belonging to the firewall. But if the ISP link is connected to some router or like modem, but not onto the Fortigate firewall, then you will misconcept or misjudge that this IP belongs to your firewall. No. Okay.
That is correct. I mean, yeah, you can find out only once you logged into the firewall and see what are the interfaces.
So, Rahul, I think there is another NAT at router level where private IP is mapped with this public IP, right? At router end. If ISP is terminated on router.
Of course they have. So for us, why we are worried about how the lab is deployed, right? For me, I'm just looking onto this.
I think that's why you're displaying public IP.
Yeah, I would also like to say something here.
Yes, tell me.
In every router, netting is already performed by the default because we are going to assign the local IP to the PCs, and it is getting netted.
Can you please come again?
What I'm saying is like in the ISP router, like whatever ISP router we get, right? So netting is already performed as a default.
On that ISP router, yes.
Yeah.
That is why port 2 having the private IPs.
Right.
So our main, I think what we need to really look at, like, is there netting is happening or not? We need to look up what is IPs actually is there, because behind the scene, Network Kings has their own stuff and they just configure port 2 as a private IPs. And we are not trying to do from that private IPs to another private IPs. So we have to take a look whether that changes or not.
See, the thing is, I send the traffic with reference to the source 192.168.1.0/24 network. If I send this directly to this Network Kings gateway now, it do not has the route to reach this back. Hence, we will lose the internet. That's why I have to translate the IP to the port 2 IP. That means the IP which has been allocated to me by the Network Kings gateway. Okay, it's the same concept that you do with your ISP link. It's just the matter of an IP, but the concept deployment is same.
Yes.
Okay.
Yes.
Bashir, clear?
Yeah. I have one, again the basic question, but relevant to the NAT. So when NAT is applicable and when it is not applicable. For example, we have different IP networks. So which type of networks NAT is preferable?
Now see, that is something. So now, okay, I will answer to that. But first, are these 4 types fine?
Yes.
It is fine. What you explained about public and private is fine for me. And only one question, why this private IP is not routable?
Why private IP is not routable?
Yeah.
Because ISP do not has a route for your private IP subnet. ISP IP do not has a route.
Oh, okay then. Okay.
But NATing is happen private to private.
Sorry?
NATing is happen private to private.
Yes. NATing is simply translation of an IP to a different IP. That can be private IP, that can be public IP. It's up to you.
Okay.
Now, see here. The question is, when I should know that do I have to apply a NAT or not? Okay. Now see, it's very easy. Let's say you have a LAN. Okay. Now this LAN is connected to a switch. The switch is connected to a router, and router is connected to the Fortigate Firewall, and Fortigate Firewall is further talking to the ISP link. Simple diagram, clear? Clear.
Okay.
Now, let's say the LAN subnet is 192.168.1.0/24. What will be the IP of this router interface?
Rohan, we are not able to see the diagram, I think.
Okay.
No.
Okay. Is it fine now?
Yeah, it's fine now.
Okay. Let's say if I say that the LAN subnet is 192.168.1.0/24, what will be the IP of this interface of the router? 192.168.1.1. Okay, let us skip it 1.1. Clear?
Yeah.
Now, What will be the IP of this side? Let's say we will call it as 10.10.10.1 and 10.10.10.2, right?
Yes.
It should be of a different subnet.
Okay.
Okay. Now, FortiGate is facing towards the ISP. So let us call it as 1.2.3.4. That's the actual public IP. Clear?
Yes. Yes.
The question is, do I really need to implement a NAT? And if yes, where? Now see the behavior. Let's say the PC here is 192.168.1.10. Okay, some our PC is here. Now he wants to reach to the internet. When he is sending the packet, the router receives it, right? The router will know, okay, fine, you want to reach where? So he wants to reach to 8.8.8. Clear?
Right.
Now, if that is the case, the routing will do what? Routing lookup for the destination.
Right.
As per the routing lookup, it found out that it has to send the packet in this direction.
Right.
So it has sent the packet out. I have not configured a NAT. I'm saying router is not doing a NATing. Okay. I'm simply okay. Now, Fortigate Firewall has got it.
Yes.
Now, Fortigate Firewall. When the Fortigate Firewall is going to receive this packet, Fortigate Firewall will say, hey, do I know how to reach this destination 8.8.8? Yes, there's a default route. I can reach it via the ISP facing interface, right? But at the same time, he will also check the routing for this 1.10. Yes or no? Yes or no?
Yes. Yes. Yes.
RPF check, reverse path check. Remember that pizza example? Okay. Now, so that means FortiGate should have a routing entry for 192.168.1.0 subnet.
Yes.
So assume that the Fortigate firewall has the routing entry for 1.0/24 subnets, stating that it should be sending via the port 1. Okay. Let's say he has that entry. Hence, the packet has been sent out. Clear?
Yes.
Now, since this is a private IP which cannot be routed on the internet, hence the packet will be dropped. This is why I have to configure source NAT at Fortigate handles. Clear?
Yeah.
Yeah. Yes or no?
Yes.
Yes. Now, just see. This is one case where you will decide that, hey, do I need a source NAT or not? This is case number 1. Let us take next example. You have a LAN subnet. He is connected to a switch. Switch is connected to a router. Okay. Okay. Router is also connected to one more switch. Okay. Yeah. And here you have a different LAN 2 as well. There is a LAN 1 and LAN 2. Okay. This router is then talking to the Fortigate. Okay. And this Fortigate is talking to the ISP, for an example. Okay. Now, this LAN 1 subnet is 192.168.1.10. Sorry, 1.0/24. And this subnet is 10.10.0.0/16. That's the subnet. Clear?
Yes.
Okay.
Now, for an example, the Fortigate firewall, okay, if LAN 1 wants to reach LAN 2, the packet will flow like this.
Yes.
Right? And the router will send the packet towards LAN 2.
Yeah.
Right?
Yes.
Okay. So it's fine. Now the LAN 2 will send a response, which will go back to the router and router will send it back. Fine.
Correct.
Do I need a NAT here?
No.
No. I don't need a NAT. Why? Because only the routing is enough. There should be a to route which will say that, hey, if you want to reach to 10.10.0.0 subnet, send the packet out via this interface. And if you want to reach to this subnet, send the packet out via this interface, right? Correct?
Yes.
Okay, now a slight modification into it. Scenario number 3, LAN 1. I will keep it simple. Switch, router to another router, then to a switch, then to LAN 2. Similarly, here the LAN 1 IP is 192.168.1.0/24. Okay, and here it is 10.0.0/16. That's the case. Now, this IP is what? Of course, it's going to fall in 192.168.1.1.
Yeah.
Okay.
Default.
This IP will fall in some, let's say 172.16.1.1.
Okay.
This IP here will be 172.16.1.2. This IP will be 10.0.1. Clear?
Yeah, clear.
Because this router is talking to this LAN network, right? So that's why I'm taking this. Clear?
Yes.
Now, on this router, I'm calling it router 1, router 2. So on router 1, I have configured the routes saying, hey, 192.168.1.0/24 network is reachable via, let's say F0/1. Okay, I'm calling this as F0/1. Okay, and this is F0/2. This is router to F0/0 and this is F0/3. Okay, so I'm saying F0/1 and I'm saying that, hey, if you want to reach to 10.10.0.0/16 subnet, you should go via F0/2. Clear? Clear?
Yes.
Similarly, on the router 2, I'm configuring a route saying, hey, 10.10.0.0/16 is reachable via F0/3.
Yes.
And I'm saying 192.168.1.0/24 is reachable via F0/0. Right? Router 2, F0/0. If this subnet you have to reach, go via this.
Yes.
Okay.
Correct? Yeah. Fine. Now, just say LAN 1 is sending the traffic towards LAN 2. Router 1 receives it. Router 1 will do what? Destination lookup. Destination lookup says send it via F0/2.
Yes.
Packet is, let me use a different thing that will make more sense. Packet is coming from here. Router 1 does a routing lookup. Packet has been sent down. Router 2. Router 2 says, hey, you want to go to a 10.10.0.0? Yes, I have a route. F0/13, correct?
0/3.
0/3. So he will be sending it further down.
Yes.
Hence the packet is reached.
Yes.
Similarly, if LAN 2 wants to send the packet back, destination now is 192.168.1.0. It knows I have to send it via this. Router 1 also knows that I have to send it via this. Correct?
Yes.
Yes.
Do I need an NAT?
No.
No.
I don't need an NAT. But if assume router 2 do not have this entry. I'm removing this. Okay, I'm saying assume router 2 do not have this entry. Only there is a single entry that is called 10.10.10 network, and router 1 has both the entries. Okay, now just see what will happen. LAN 1 is sending the traffic. Router 1 it will say, hey, what is the destination? 10.10.10.1 or 10.10.10. something. He will router 1 will say, yes, it is via F0/2, correct?
Yes.
So the packet will be sent down. Router 2 receives it. Router 2 is doing what? It will say, okay, what is the destination that you want to reach to? 10.10.0.0/16. Yes, I have a route that says F0/3.
Yes.
Yes.
Our router 2 will also send the packet down, and hence the packet will reach to the desired destination. Correct?
Yes.
Now the reply packet is coming back. Now the reply is coming back. So LAN 2 is now sending a reply. That reply packet reaches the router 2.
Yes.
Destination 192.168.1 dot something, right?
Yes. Yeah.
So router 2 will do the routing lookup. Does it has a route?
No.
No entries. Yeah.
No entries. Packet is
Drop.
Dropped.
What is the solution to that? The solution is two things. First, either you configure a routing entry in the router 1 to
Yes.
tell that, hey, how you can reach this subnet? What we did earlier, yes or no?
Yes.
Yes.
Or NAT. Or you can enable NAT on router 1. You can configure the source NAT on router 1. You can tell him in the first place only that, hey, when you send the packet out from you, you actually translate your source IP to 172.16.1.1, right? Because router 2 has the entry for this network. Directly connected network is there, na?
Yes. Yes. Directory is always there.
Right?
Yeah.
So if router 1 sends the packet by translating the source IP to this interface, there is no need to configure an additional route for this on the router 2.
Yes.
Clear? So
Yeah,
this
clear.
is what I wanted to explain you. Now see here, how you will decide whether you have to configure a NAT or not, source NAT or not. The answer to that is if the next hop device, please be on mute. Please be on mute.
Yeah.
Okay. See.
So, Rohan, just one question before you go into the further. So, do you really see those kind of netting in between router inside the LAN?
Yes.
You see it? Oh, okay.
There are. If you have a DC kind of a setup, it is not necessary that all the devices will have the routing entry for all the subnets. Okay.
Yeah.
It is not the case. And secondary, it is also not possible that while you are working, you may have the access to all the devices. Okay. Maybe a certain next hop device is not in your location. It is in a different branch or a different site. Okay.
Yes.
Such a situation where you cannot add a routing entry into the next hop devices, there is no other option than to configure a NAT onto your device. Okay, so this is why whenever the next hop device is not having the route to reach back, that is when you will enable the source NAT on this device.
I see. Okay, thank you.
So never confuse, do you have to configure source NAT on router 1 or router 2? That's not the question. It's always the question about, does my next hop knows how to reach back? If he knows how to reach back, you do not need to configure any NAT. But if the next hop device is not aware how to reach back, then you may send the packet, but the reply will never reach to you, right? This is why you have to enable the source NAT onto your device. Clear?
Yep.
Clear. Okay.
Clear.
So two cases of NAT implementation. First, wherever you want to reach to the internet, that is, you want to ensure that your LAN users are able to reach to the internet. Of course, you have to do a source NAT because private IPs are not routable. So you have to translate the private IP to the public IP. Second is this case. Whenever the next hop device is not aware how to reach back, that is where you will be enabling the source net onto your device. Clear? Have
Yeah.
this concept in mind, okay?
Yeah.
You will be able to implement netting like a piece of cake, okay? You will never be confused. It's all about logic. There is a logic. Nothing is guess, okay? Fine then?
Yes.
Okay, fine. If anyone has a doubt, please refer to the video, okay? Please refer to today's class video, okay? Go through it. I've repeated the things again and again and again, but still if you have a doubt, you can ask me and I will be again repeating the same thing, not a problem. But I want you to have a core focus onto it. Do not confuse. It's simple. Now, see it. Okay, I think you're not seeing my browser, right?
No.
Okay. So see, with reference to, I told you that, see, this is one way to enable the source NAT, right? And the other way was using the central NAT. Now see, what is a central NAT? Central NAT is nothing, but you are doing a NATing with terms of policy. Okay. So if you want to go with that approach, you can also follow that. Let me show you how you can do it. Okay. Mainly, someone in out of 21 customer may be using this. Okay. That depends upon person to person, man. Okay. So if you are someone who loves to manage the NATing with reference to policy, you can go with this. Let me enable that central NAT. Now see here, central SNAT. I'm turning it on. Now focus on here. I don't see any option of central NAT. Okay. Whether we were having an option to enable a source NAT on the policy itself, right? Now I am going to enable central SNAT here. Once I enable the central SNAT from the system settings, okay. Now see what happens. Now if I go in policy and objects, you see here, there's a central SNAT, right? Right?
Yes.
Now, if I show you the fire policy in the first place, let me show you that. See here what it will say. I will go, the policy looks exactly the same what we saw in previous. The only thing that you will see is with the NAT option. Now see, earlier we had a NAT option here, right? Which we were turning it on. Now what it says, central NAT is enabled. So NAT setting from matching central SNAT policies will be applied. So he's saying, hey, now you do not have to configure the NAT on the policy. Rather, whatever the central SNAT policy matches, based upon that, the NATing action will be taken. That means here you will go into central SNAT and then you will create, okay, the policy. So incoming interface, port 1, outgoing interface, port 2, source address, I will say all, anyone, destination all because I want to send them to the internet, enable the NAT, that is source NAT, okay, use outgoing interface address or use dynamic IP pool, the same thing, okay, the same thing. You have done, enable this, press OK, and it's done. So you have configured a policy which says that if any packet, if anyone who wants to reach anywhere is coming on port 1 who wants to go out to port 2, that IP will be translated to outgoing interface IP address. Hence, the translation will happen. So this is where you will be configuring all the SNAT policies. So instead of doing on to the firewall policy, you are actually maintaining a different set of source NAT policy. Now, why I mentioned that the people do not tend to use this ideally is because if I am already creating a policies, so why not to just enable that single option rather than creating another set of policies, right? For the same thing. Correct or not? Okay, so I leave it up to you all. Okay, it's like person to person view. If you are happy with going with a central SNAT approach, you can also follow this. If you are someone who is willing to be as simple as possible, go with firewall policy option. Clear? Clear?
Right. Clear.
Yes.
Okay. So okay. Let me turn this off first. Where it is? Yeah. Okay. Now, like I told you, I will tell you about a situation where I was stuck. Okay. So the situation was that there was a customer. Okay. There was a customer who was it's like who just logged a P1 and he was literally shouting, man. Okay. And what happened is he said, hey, I'm having a complete outage. Okay. It's kind of an partial as well as complete outage. Now that is a contradictory statement. Either it is a complete outage or it's a partial outage, right? But he said it's kind of in both. So, okay, fine. So what's the nature of the outage? So the nature of the outage is, let's say you are trying to access Google. Okay. So Google will not work for you. But if you keep on trying, let's say you are refreshing your page 5 to 8 times, at the 8th time, the Google page will open. Okay. So you have got the Google page. But if you try to search on it, it will show you the search result. But if you wait for just 10-20 seconds and then again you try to search a new thing, it will say it's like there is no internet access. So again you have lost the Google page. Now again you have to keep on trying for 8 to 10 times and then the Google page will open. Okay, so that's why he was saying was a complete outage as well as partial in a nature, because few of the people are sometimes able to access the internet, but the same person is not able to access the internet after a few minutes or few seconds. Clear? Got the issue?
Yes.
So that was happening for the entire company network. It's like whosoever was working onto that company, they all were facing this issue. So at the first instance, okay, my colleague thought that the issues with the ISP, maybe we are getting a ping drop, right? So we tried to test up a ping. He did a continuous ping test, okay, in order to see that whether the ISP is like showing us success, drop, success, drop. So if we see such an behavior, we can see that, hey, the ISP is doing that, right? Sometimes it is accepting the packet, sometimes it is dropping, right? Yes or no?
Yes.
First thought. So he did a continuous ping test from where? From the Fortigate Firewall. He did that. Okay. And when he did that, he saw ping is working fine. He sent 100 of packets, 100 was success. No issue at all. Success. Ping was going successful. So the issue is not on the ISP. Asked for the topology. What is the topology, man? He said the topology is simple. I have a LAN, I have a switch. There is another core switch deployment, which is in a cluster. Then we have, they had some routers and all, and then the traffic was coming to the firewall. Firewall was then sending it outside. Okay, fine. So then we try to see whether the issue is on the firewall or after the firewall or like before the firewall. When we took the capture, what we saw is we are getting all the packets. We simply asked him that, hey, do one thing, take one PC and try to ping. Okay, try to do a continuous ping. Okay. When he started doing the continuous ping, what we saw is we are receiving each and every packet on the firewall. Okay, but he was sometimes getting a response and sometimes he was not. Okay. We tried with a different set of ping with the different IPs like 8.8.8, 1.1.1. We saw sometimes it was working, sometimes it was not. When we took the debug, what we saw is IP pool exhaustion. Okay. We saw the IP pool was getting exhausted. So he had actually 5 public IPs. Okay, he had 5 public IPs. And he had the overload configured onto it. Okay, overload means many to one. Getting my point? Okay, so he had configured like this. He was doing in this manner. Overload, and he had 5 IPs. That means 1.4, 3.4 to 3.9, 5 IPs now. So each IP can handle how many sessions? How many unique sessions?
64,511.
65535 minus 1024, right?
Yes.
That much unique port a single IP can form, right? With a single destination, right? With a single destination, that many sessions can be formed, correct? That's a huge number, man. Okay, so even with a single Google, those 65,000 sessions can be formed at the same time using a single IP, and he was having 5 public IPs. That means multiply it by 5. Just assume, man, multiply it by 5. So that's a very, very huge count, right? Yes or no? 65,000 into 5, so it will come around 530, 525, it's like near about 3.2 lakh, right? So 3.2 lakh sessions with a single destination can be formed. That is, if someone wants to form 3.2 lakh sessions with Google, that is possible. That is what it was capable of doing, because he was having 5 iSplit. Still, his pool got exhausted. That means the firewall was saying, I am out of the combination of IP and the port. Now there is no unique port and IP that I am left with. Henceforth, whatever the session that I am getting or whatever the packet that I am getting, I cannot do the NATing action. Now there is no uniqueness left into that. Hence, I will not translate it and I will drop the packet. Clear?
Yes.
Clear? So the port was exhausted. The IP was exhausted. Now that's a huge count. We immediately check the sessions. How you will check the sessions? Dashboard. In the dashboard, you have a session chart. Yes or no?
Yes.
You have interface bandwidth graph.
Yes.
Source, incoming and outgoing. We checked both. What we saw is the session count was very high, as well as the LAN interface, the interface which was facing towards the LAN. It was showing us a very high graph of packet. It's like the traffic was too high. Okay. So we asked him, is this the ideal traffic usage that you expect your firewall to handle? He said, no. I'm not sure why we are seeing such a high amount of traffic. I'm exactly not sure. And if I remember correctly, there were few millions of sessions. Okay. That the count that I was seeing onto that device. Okay, then since it was very, very high network and it's like high thing and all, okay, the topology was too high. It was kind of in data centers and all. So it was really tough to give him a quick call that, hey, these are the IPs and all. And because we needed some time to work onto it, right? And the customer was losing the patience. He was saying, no. Whatever you think you want to do, you do it. But first of all, fix my outage. Mitigate the outage in the first place. Then all you continue all with your troubleshootings. And like troubleshooting such a large network, of course, takes time. That is when that case came into my hand. When I saw all this, the first thing that came into my mind is the issue is with the session count. That it's handling very, very high amount of sessions. If somehow I can limit that session, then I can mitigate the impact of the outage, right? Because after all, the core issue was pool, IP pool was getting exhausted, right? So I have to prevent that. That is when I came to know about port block allocation. Because in the entire NAT type, okay, This is fixed port range, man. Okay, so I will not count this because this is 1-to-1, man. Okay, here that is not possibility, right? There are many users. Okay, so I cannot do a 1-to-1 map. So I am ruling this out. This cannot be the option. 1-to-1 is also not an option. Overload is an option, but here the session count is too was that high that the IP pool got exhausted. Okay, so the only option that was left was port block allocation, because it said it gave us a functionality to limit the sessions per user, right? Yes or no? Like
Yes.
I mentioned, that here if I give 100, so that means 800 sessions per user can be formed, right?
Yes.
So this is how what
Rohan, I have wondered, so what is outage means?
outage means. Entire thing is down.
Downtime.
It's like you are not able to work. It's like the internet is not working. Your applications are not accessible. You are not able to access the servers. Everything is down. Okay. Now see here. What happens here is, so that is where I use the same range, but here I limited the sessions. I told him, okay, ideally, how much sessions your users will be dealing with at the same time. He said 100, 200 will be fine. We gave him 300 to 400. I like remember that is what I did, something 500 or 600 sessions per user. I pressed OK, and the entire session that was showing high, that immediately came down. Okay, and everyone was started working. So everyone was seeing that, hey, my internet is working, everything is, application is back, servers are working, everything was back. Okay, so the issue was mitigated, the outage was resolved. Now the question is, why did that happen? Answer to that is, there was a very high traffic that I was getting from the LAN side. The customer himself confirmed that that is not expected. So who is that person? FortiView helped me in that. Okay, FortiView sources. Okay, not only that, you can also check with reference to destination pairs and all. So this actually showed me how many bytes each PC was using. So actually, later on, it was informed by the customer that one of his subnet was compromised with botnet CNC. Okay, so botnet CNC was compromised it, and they were sending a burst amount of traffic to the botnet CNC server. So it's kind of a malware that infects your system and it starts leaking your data. Okay, to ensure, it's like you can think if it kind of in DOS. Okay, that will overutilize your devices. Okay, so that is what he was seeing. So we pinpointed he was having the Forti analyzer. So he like quickly caught up and report, and we saw that there was a list of few IPs which was falling in the same subnet, and those were generating a very high amount of traffic. When it was traced back, it was found out that it was some sort of different vendor LAN laptops and all. So those were compromised. Okay, once they removed those systems from the LAN, everything went back to normal. Okay, so see, even a slightest issue, no matter what the thing is, okay, you may see several implications of that. Okay, so why I shared this to you is, whenever you do a troubleshooting, okay, do not jump to a conclusion. It's always about approach. The approach is, there can only be three things. Whatever the thing that you troubleshoot, okay, there can only be three things. I am a Fortigate Firewall engineer. You may be having n number of devices here. You may be having n number of devices here. My approach is, either the issue is after the firewall, before the firewall, or on the firewall. There cannot be fourth issue. Can there be? No. No. Either the issue is before the firewall, after the firewall, or on the firewall. Three things. So my job is to narrow it down. First of all, rule out where the issue is. Do you see the issue at this side, or on this? If the issue is at this side, you are responsible to resolve this. If the issue is on either of this side, it's not your job. Check on the next device. So it's all about the approach, and the approach is something which I will be discussing.
I think your skin is not that not visible.
Screen is not visible.
That whiteboard.
Oh, okay, okay. Oh, sorry onto that. Is it now?
Yeah, now is visible.
Okay, so I was simply saying that the issue can either be after the firewall, before the firewall, or on the firewall. Yeah. Okay? So your approach should be in a way, okay, it's upon person to person, but what I'm saying is it's never about the solution. It's always about the approach. You have to mitigate the issue. Okay, so you have to narrow it down. Does the issue lies here, here, or at this side? Okay, so whatever, so that's why basics is very important. What is the packet? You have to understand the topology. You have to understand the nature of the issue, nature of impact, how it is happening, what it is impacting. Take certain basics, logs and debugs. That is where you will get an insight what is going on. Okay, so we got a first breakthrough when we saw a debug. Okay, when we saw that the pool is exhausted. Okay, that was the breakthrough. So one thing was clear. That is when we jumped. Okay, that hey, why the pool is getting exhausted? So we saw a very high amount of traffic, then we try to mitigate it. The answer to that is if I'm seeing a very high amount of session, of course, pool is getting exhausted, right? The firewall is shouting to you that I don't have any ports left that I can use to NAT it, right? So what's the answer to that? That means you have to limit the sessions, simple. And who will help you to limit the sessions? There is only one NAT type that can help you to limit the session. That is port block allocation. There is no other NAT type which will help you to mitigate the session. Okay. And that was the first time when I knew about port block allocation, because I was also thinking, how will I achieve that? I knew that what to do, but I was not aware how to achieve that. So that's why when I started reading the document, then I got out, hey, that there is a port block allocation NAT pool. He saved my day, man. Okay, fine. We will continue tomorrow with DNAT. After DNAT, we will be seeing the debugs. Okay, there the debug will make much more sense once we complete the DNAT. Okay.
Right, Rohan. It was a good knowledge share today.
Okay, man.
Yeah, agreed.
Yeah.
Absolutely.
Yeah.
It was really good.
Thank you.
Okay, man. Sure. Thank you.
Thank you. Bye bye.
See you guys tomorrow.
Yeah.
Yeah.
See you tomorrow. Thank you.
Okay. Yeah, thank you. Good night.
Okay,
Good night.
Thank you. Good night.
Thank you. Good night.
Thank you. Good night.
Thanks. Good night. Thank you. Good night. Good night. Good night.